In this lesson, we are going to take the Solidworks part you see on the screen and convert it to a sheet metal part. Now, if you would like to work along with me, you can find this part file in your Working Files folder under the name Convert to Sheet Metal Part. So let's begin. First, we need to locate the command for converting this part to a sheet metal part. One option is to go to the Insert pull-down menu, Sheet Metal, Convert to Sheet Metal, or the faster option is to go to the Sheet Metal ribbon and select Convert to Sheet Metal. As soon as I select the feature, the Property Manager appears and the part is shown as transparent. The very first item in the Property Manager allows you to use a gauge table. Now, if you choose not to use a gauge table, you can specify those values as you work through the Property Manager, and that's what we're going to do. The next item in the Property Manager is prompting me to select a fixed entity. This will be the face that remains stationary as the part is converted to a sheet metal part. So I am going to select the bottom surface. And notice when I do that, we see a preview for the sheet metal thickness. That thickness is currently at 10 millimeters and is inside of the Solidworks part. Now, if you want to create or build the sheet metal part on the outside of the Solidworks part, you do have the option to reverse thickness by placing a check mark in this box here. And notice the preview updates. I am going to change the material thickness to 1.5 millimeters. Moving down the Property Manager, I am now prompted for a bend radius. And if you recall, this is an inside bend radius. I am going to use a value of 3 millimeters. Next in the Property Manager, I have a window to select bend edges. So I'm going to go out to the screen, and it's always good practice to select the bend edges around your fixed face first. After I select those edges, notice the bend edges are pink in color, and then I have 4 other edges purple in color. The pink edges are bend edges, and the purple edges are rip edges. We also have these tags here, which are shown up on the screen. This allows you to change other settings, like gap distance or radius. I am going to continue selecting bend edges, so I'll select this edge here. I'm going to roll the model and select these 3 edges here. As soon as I do that, looking at the model, it appears all edges are either pink or purple in color. Working down the Property Manager, we see a window for rip sketches. We'll return to that later in the lesson. I then have the capability to control different corner options: open butt, overlap, underlap, just like we had with other sheet metal features. I am going to leave it at open butt, and we also have the option to change the gap distance and overlap ratio. Right below this, you see we have bend allowance, currently at a K factor of 0.5, and a relief at rectangular with a ratio of 0.5. We'll keep those settings and close out of the Property Manager for Convert to Sheet Metal. Notice on the screen, we have a sheet metal part, and if I roll the part, you can see the bend edges and the rip edges and how they appear. Let's go ahead and flatten the sheet metal part, and we have a symmetrical flat pattern. We will unflatten it. Now let's assume we decide later on in the design process we want this edge here and this edge here to be a bend edge with a rip right down the middle of this face here. How would we go about doing that? We need to return to the Feature Manager tree and take the rollback bar and roll it back before the sheet metal features. We will then create a new sketch on this face here, and then draw a line from midpoint to midpoint. And that's going to be our rip line. I'm going to close out of the sketch, bring the rollback bar to the bottom of the Feature Manager tree. I will now edit the Convert to Sheet Metal feature. And even though I can go through and carefully deselect a couple of these as I add this new rip edge, to make this lesson a bit more cleaner, I am going to clear the window for bend edges and reselect them. I'm going to select the edges around the fixed face. I'll select my 2 new bend edges. And notice I received an error message when I try to select this as a bend edge. It says this edge is a rip edge and cannot be selected as a bend edge. What I should have done before selecting this as a bend edge, I should have went down the property manager and selected that new sketch line inside of this rip sketch window. So let me do that. The sketch line is added to this window. I'll return to my bend edges. And now let's see if it works. And it did. It picked up that far edge. I'll select those back 3 edges like I did before. And because the part's transparent, I do not have to roll the part. Looking at the model, everything is selected. I am going to close out of the feature. And what I see on the screen is not the result I was looking for. I was hoping to have a rip edge along this edge here and this edge here. So notice, if we roll the model, it's not what I was looking for. If we try to flatten this, we will receive an error message, just like this. I'm going to close out of it, unflatten the part. How would we go about fixing this? It's actually pretty simple. We simply expand the Convert to Sheet Metal feature in the Feature Manager tree, and we edit the sketch we just created earlier. I'm going to add 2 new sketch lines from this point to this point, and from this point to this point. I'll close out of the sketch, collapse my Feature Manager tree, and notice on the screen, that's the part we were looking for. It's symmetrical and it can be flattened into a nice symmetrical sheet metal part. Let's go ahead and unflatten the part, and this concludes our lesson on converting to sheet metal.